Escaping Earth's gravity requires a staggering 11.2 kilometers per second of velocity, plunging straight into a deadly, airless vacuum. For decades, the astronomical cost of generating that kind of raw power kept early spaceflight concepts trapped strictly on paper. It took an existential geopolitical threat to force open the treasuries. The Cold War turned theoretical rocket science into an urgent military priority. National survival, rather than scientific curiosity, drove the first launches. Rival superpowers paid any price necessary to capture the high ground of orbit first. When the Soviet Union successfully placed Sputnik 1 into orbit, it sent a shockwave through the United States, triggering a frantic sprint to catch up. Missions accelerated at breakneck speed. By 1961, Yuri Gagarin successfully orbited the Earth, proving that the human body could endure the hostile conditions of space. To push heavier payloads further, engineers relied on a brute force methodology known as staging. By building rockets in stacked segments, the vehicle could discard depleted fuel tanks, shedding dead weight to continuously accelerate the remaining spacecraft. This philosophy culminated in the Apollo program and the Saturn V. Standing 363 feet tall and weighing over 6 million pounds, it remains an astounding feat of engineering scale required to reach the moon. But this methodology hid a devastating economic flaw. Every single launch meant dropping hundreds of millions of dollars of highly complex machinery straight to the bottom of the ocean. Once the political race was won, the blank check budgets vanished. Humanity had reached the moon, but we were left with a financial model that was impossible to sustain. In the 1980s, NASA attempted to solve this cost trap with the space shuttle. By employing a partially reusable orbiter and recoverable solid rocket boosters, the agency aimed to make low Earth orbit routine and affordable. The shuttle's massive cargo bay allowed astronauts to ferry heavy infrastructure into orbit. This physical capability paved the way for diplomatic collaboration, allowing international space agencies to build orbital hardware together. The result was the International Space Station. Former Cold War adversaries spent over a decade uniting their engineering capabilities, establishing an orbital laboratory that has maintained a continuous human presence since the year 2000. Then, in 2005, Congress passed a critical piece of legislation, officially designating the U.S. segment of the ISS as a national laboratory. This legal shift opened the station to the global market, allowing private corporations and universities to lease laboratory space for proprietary research. Seeking to focus on deep space, NASA began contracting out basic cargo deliveries to the ISS. This created guaranteed contracts, providing a lucrative opening for private aerospace companies to step in. A startup named SpaceX seized the opportunity. They bet their entire business model on a radical approach to alter the core economics of launch: total recovery of the rocket's first stage. Propulsive vertical landings finally allowed engineers to fly the booster back, recover it, and launch the same hardware again. This chart shows launch costs per kilogram over time. Notice the astronomical prices during Apollo compared to the steep drop from the reusable Falcon 9. As costs plummeted, the barrier was removed, allowing companies to deploy thousands of commercial satellites. By cracking the economic bottleneck of disposable hardware, private enterprise built the third era of spaceflight. Orbit is now a thriving, self-sustaining commercial ecosystem. Cheap, reliable access to low Earth orbit has allowed companies to blanket the sky with mega constellations, providing continuous, global digital infrastructure to the surface below. To scale this economy further, engineers are currently testing fully reusable, super heavy lift systems. These vehicles are designed exclusively to haul massive payloads and conduct in-orbit refueling. Rockets have evolved from bespoke exploration vessels into standardized freight trucks of an expanding off-world economy. This immense commercial hauling capability is now fully integrated into NASA's Artemis program, providing the logistics required for the imminent return of humans to the lunar surface. Artemis focuses on long-term sustainability over short-term symbolism, utilizing in-situ resources to build permanent infrastructure like the Lunar Gateway. Over 70 years, we have dismantled the massive physical and economic barriers of gravity. Humanity has finished visiting the final frontier. We are moving in,